I have been, I don't know how long, I've been starting to put together information about the whole Upper Clark Fork data. Started looking at how do all of these pieces fit together and doing a lot of analysis. I started putting together some PowerPoints and I've given them to people at ARCO, at EPA, at DEQ, and Montana Tech. This particular one was a takeoff from the last one I did with DEQ, and that was the second one for DEQ. I met with their water quality folks because they are looking at something called, they're starting in on a use attainability analysis, which simply means they are going to look and see if they can change the classification from I to something more appropriate, I guess. And now that we've made progress, as you'll see on Silverbow Creek, I don't know why I came with the term "the sound and the fury" came to me one time, thinking about all that's gone on Silverbow Creek, and I've read the book a couple of times, but I love this sort of lurid painting that went along with it. So anyway, this is a tale told by a geologist, and it's the environmental history of Blacktail Silverbow Creek with special appearance from Warm Springs Creek. So that's Silverbow Creek right in, that's the Butte Reduction Works. And this is just downstream of Butte, maybe half a mile, FWP, shocking and counting fish, but looks pretty nice, doesn't it? So in my mind, and I've talked to DEQ about this, it's like, gosh, you know, it's kind of see the light at the end of the tunnel, can't we? What would it take? So spent a lot of time kind of learning about the whole Superfund or the CERCLA process. And it's a balance, or it's a circular reasoning thing between science and law, and we'll get into that in a minute. It's certainly more complex than a simple board game. But critical to all of this is that record of decision. Because in this process, that sets out a remedy. It's a fixed point that you can finally get traction off of and move forward on the cleanup. So the good thing is the rod locks in the remedy. The bad thing is the rod locks in the remedy. So you've lost a lot of flexibility. Unless you have something like a TI evaluation and you decide to change something major, then you have to go back and amend the rod. And all of this, of course, is we're kind of familiar with, builds up to something like maybe a consent decree.
What does TI stand for?
Technical impracticability. And I'll bring that up a few times, but
Thank you.
Good question, really. And I appreciate that, Aaron. There's several ways that then you can move forward. It doesn't have to be a consent decree. EPA can order the work done. In this case, Atlantic Richfield would either abide by those orders or say, we'll see you in court. And then everything goes to hell. So anyways, I look at the long history of devastation of Silverbow Creek as this sort of conceptual ecologic history. And as it starts to, it tends at the bottom, so that pristine's on the left, and it gets degraded in this rising curve, and then it starts coming down as we do different things to manage the environment. At some point it becomes asymptotic and starts to flatten out. And that's the point where you need to start asking the question, do we need to do more with the rod? And so here are those waivers. The way CERCLA is written is it's at the president's discretion. Kind of an interesting thought right now, but no matter what the remedy has to be protective of human health and the environment. So the two kinds of waivers I've seen apply, the first one is compliance with such requirement at the facility will result in greater risk to human health and the environment than alternative options. So that's really a do no harm waiver. I've only seen one of those in the entire Upper Clark Fork complex. The other one is a technical impracticability waiver. And that just means from an engineering standpoint, we don't see any way we're gonna meet what we're supposed to meet. So let's talk through where these different parts of this Upper Clark Fork is right now. So currently, and of course, that's the Berkeley pit in the lower right. There's Silver Bow Creek going up to the Warm Springs Ponds. In light blue are the four streams of the Anaconda Smelter site. And then it goes to the Clark Fork, and the star at the upper part is Deer Lodge. The stars are USGS, United States Geological sampling and gauging stations, and they've been operating since the latest 80s or early 90s. The red dots are DEQ sampling stations. I don't remember when they really fully started on theirs, but they sample quarterly. Anyways, Butte mine flooding, it had a TI waiver. Sometimes there's just a TI analysis waiting on a waiver, but it's also had a consent decree. So everything's agreed to. Atlantic Ridgefield and the mine have agreed to do the work. So it's kind of set aside. The red line around the Berkeley pit is the area where groundwater is captured. So it's all moving to the Berkeley pit. So that's a capture zone basically. Butte Priority Soils has two TIs, two TI waivers, one's for groundwater and one's for stormwater. And of course, we all know there was a consent decree that, like I said, defines all the work that will need to be done. Over in Anaconda, there have been 3 TIs, and it's now in consent decree. The 2 of those are actual TI waivers. One of them is a TI analysis, and the CD basically said, ARCO, here's the work we expect you to do. We, at this point in time, see nothing else you could do. We're not giving you the waivers up front, but we'll give them to you after you do the work. Maybe they'll figure out, wow, there's actually a silver bullet. You guys have to apply the silver bullet now. And then there's the Clark Fork. It has 1 TI, and it was strictly for TI waiver, it was strictly for total recoverable copper. And it was not an analysis or anything really. The EPA project manager just said, we'll never meet total recoverable copper, and I'm waiving it. There was a consent decree quite a while ago.
And the Clark Fork goes all the way to Milltown from Warm Springs Pond.
Yes, it does.
Yep.
The majority of the work will be done from Warm Springs Creek down to Garrison. Beyond that, they don't see very much going on. Warm Springs Ponds is basically sort of still in its infancy. And it has an interim rod. It closed the pond 1, and the basic thought was we need to wait and see what's happening upstream before we finalize this. They are now getting pretty serious about moving forward with where Warm Springs Ponds will be going. So that there's, my Google Earth aerial view. So the dark blue is basically Silver Bow Creek. And I didn't blue out the ponds, but there's Silver Bow Creek as well. The light blue are from the top, it's Willow, Mill. They combine together to become the Mill Willow bypass right alongside. They're isolated from Silver Bow Creek. And then they meet up with Silverbow Creek right at the discharge from Pond 2. And then we have Warm Springs Creek coming in, and then it's the Clark Fork. So, this is kind of my story. What would I do if I were king? This is, I just went and saw Hamilton this weekend. And really, I have to say, I really, really believe, after all these years, I really believe in the effectiveness of the Superfund process. So what I'm saying is going beyond that in some ways. It's an appeal maybe to other people, but so this is what, so if I was king, and is what I've done is I've taken all of these different sets of data and incorporated them into kind of this story, more or less. But on the left are entities collecting data. I put Montana Tech there and not University of Montana because Montana Tech is actually 10 years ago, Alicia Cox started in on collecting quarterly data across a variety of stations all the way to Drummond. So from actually Upper Blacktail Creek all the way to Drummond, she collects chemistry, and they're also collecting something that's at the bottom over there, eDNA, that's environmental DNA. And they're mostly looking now at the microbial population at different points. And they look at it both in the water column and in the sediments. I think that I couldn't tell you why it's important right now, but I think 10 years from now, we would be going, boy, it's a good thing we collected this because it is telling us something. So
Hopefully the positive direction.
yeah, and that's the way science really works. So in my mind, I want to reevaluate the science, and the way I wanted to do that is a reference stream approach, or you could call it a weight of evidence approach. So you kind of look at all these disparate things, and then you say, hey, this seems to be affecting that. And there's different ways of doing that. Yeah, and I think key to that is looking at Warm Springs Creek and Blacktail Creek both as reference sites. And I'll get to why that is. But keep in mind, this is this is if I were king. So how is this upper Clark Fork watershed broken up? Well, we can see that Blacktail Silverbow Creek is 335 square miles where it first enters the broader Deer Lodge Valley. So these are cut off at where a confined bedrock stream then enters this big valley, and then there's an intricate interaction between groundwater and surface water, so that's why I cut it off there. Warm Springs Creek is about half that big, and then the other three Anaconda streams are pipsqueaks. But this is kind of interesting too. This is daily average flow through the period of record. So each point on there is actually a day. And you see it goes through the year, and we can see spring runoff. And as what we see is Silverbow Creek runs off way sooner than Warm Springs Creek. It never goes quite as high, and it's done with its spring runoff sooner. And then in the late season, it's actually less flow. So if you kind of sum all of that up and turn it into acre feet per year, Silverbow Creek is almost 40,000 acre feet, and Silverbow Creek is 40,000, and Warm Spring Creek is almost 44. So hydrologically, Warm Springs Creek is superior.
A larger watershed.
Yes, a lot of, well, not only, no, it's a smaller watershed, but it provides more water to the Clark Fork.
Okay.
Does that make sense?
More volume.
More volume of water. And it provides it later in the season, so it's more cold, clean water going to the Clark Fork. So then going back to, you know, the part we're familiar with where what was historically Silverbow Creek meets Blacktail Creek. And we can see that Blacktail Creek is 91 square miles and the upper Silverbow Creek is 24 square miles. The little red circle, of course, is the confluence. But it means that Blacktail Creek's actually almost 80% of this watershed. So I think I might want to try and rename it to Blacktail Silverbow Creek or just Blacktail Creek. But anyways, here's the way under Montana law, this is the way the state of Montana looks at it. And I mentioned to start with that I gave this presentation to DEQ because they are looking at reclassifying Silverbow Creek. And this is one of the slides. And I have no shame in calling it the MSD, but it is unclassified. The state looked at it and went, never gonna be. We're not gonna classify it. They've classified Blacktail Creek as B1, which is about the highest it can be classified unless it's a special water source. It can be given A status, but that's a real special classification. B1 means it should be good for drinking and swimming in, and it should support aquatic life that we would expect, including salmonid reproduction, actually. So they come together and they become Silverbow, and it's considered high class. I stands for indeterminate. So at the time, they started this classification system in 1955, and they said, what are we gonna do with Silverbow Creek? So they just said it's indeterminate at this time. So they had expectations. So here we are at the confluence, and this is again, hey, don't do that. That is Blacktail Creek on the right. It's MSD or Upper Silverbow Creek on the left. And this is important to this story, and I'll show the same slide one or two more times. But those are children on the bank, and that's a fishing derby. And Blacktail Creek was not a bad creek back in the 50s, or I don't know how far back, but you can see it. It's really barren, and they've straightened the channel. That's a really straight channel. And basically on the side, they've excavated and they've piled that junk up on the sides. So some of that is probably contaminated because it's at the confluence. And
that would be the Blacktail burn, right?
Yep, that is the Blacktail burn. This,
Yep.
Yeah. So you may ask yourself, how did we get here? So this is a view of the Butte Reduction Works, the facility in the background there. This is Silverbow Creek in the center, and on both sides are tailings impoundment from the Butte Reduction Works. You can see they've taken out some of the cribbing, so it's decanting some of the water back into the creek. But there are two problems that are being dealt with under Superfund, main problems for Silverbow Creek. One is that all of the milling and smelting operations in Butte at the before and around the turn of the last century just simply slurried their tailings out into the floodplain and into the creek, because it just would carry them away and then they could dump some more in there.
This is probably by the kind of by the
Sewage treatment plant, probably.
Yeah.
And the other main problem was the direct discharge of acid mine water into Silverbow Creek. So as far as the history of producing tailings, these are all of the main mill smelter works. And you can see it started in sometime, the earliest 1880s, but it was done by like maybe 1910. So the history of us producing tailings and putting them into the creek ended a long time ago. But of course, in 1908, there was the flood of record across the state of Montana, and it washed tailings all the way down, certainly beyond Milltown Dam, but it used up about 70% of the reservoir capacity in this one incident, and it filled that up with regular stream sediments and of course a lot of tailings. That's why it became, Milltown Dam became its own operable unit. But the other thing is, from 1880 to 1982, when they turned off the pumps, acid mine water was going down Silverbow Creek. So keep that in mind. That was a constant input to Silverbow Creek, and from Silverbow Creek probably to groundwater along that whole 26 miles. So here's what we're going to look at a little bit of. You may think that the Anaconda Copper Mining Company didn't care about any of this, but they did. And this is kind of an interesting one. This is from, I think this was, well, it says 1932 to 1947. So this is how they looked at Silverbow Creek. So there in the lower right hand are those are the precipitating business. So they would take mine water, they would run it over scrap iron, they would extract copper, and then they would release that water, and it was still like, this says 3.5. So it starts down Silverbow Creek at 3.5. At one point, they took some of the water out of Silverbow Creek and they ran it all the way up into the Opportunity tailings ponds, so that it would mix with the tailings. And the reason they were doing that is mine water's at 4.5, tailings are at 11. So they're trying to neutralize Silverbow Creek. And all of those circles show that they're paying attention to how they're dealing with the pH of Silverbow Creek. And then in the last two circles on the right, one of them says pH station, so they're checking it there. Then it says river pond, those are the Warm Springs ponds. And then there is a pH shack just beyond that. So finally, when it's becoming the Clark Fork, they were trying to have it be a pH of 7. As far as Silverbow Creek itself went, it was still just an industrial sewer.
So they also have Silverbow Ditch, so that ran it across,
Yes,
what, into Opportunity Ponds.
yes, and that came to be called the Yellow Ditch. But it was, I think it was also called Silverbow.
Yeah. Well, that's what,
Silverbow Ditch. So, you know, going back even farther, they built the first of the Warm Springs. So 1908, we had this flood, tailings everywhere. I've heard two stories. One is 1911, one's 1918. But anyways, they started building the ponds to retain any more tailings from going down the Clark Fork way back when. This is an action by the Anaconda Copper Mining Company. The last pond was Pond 3. It's the largest pond that was built in, I've heard different dates on that too, 59 or 60 something, but it's fairly recent. But also the Opportunity tailings ponds, they started, when they built the big Washoe smelter, they started saying, we're not gonna slurry any more tailings down to the Clark Fork, so we're gonna start retaining them. Not true of the old works. So Warm Springs Creek got the same treatment as Silverbow Creek in that the old works slurried their tailings down Warm Springs Creek.
Did they have a sense of liability?
Yes.
Okay,
Yes, there were nuisance lawsuits.
okay.
I think that was a trigger for it. I don't know. I can't speak for the So, heading back to what's been done about it. So this is the story of environmental management under Superfund. And it was not, well, maybe this might have been really the first decision that was made anyways, maybe. It wasn't really much of an action, but they looked at, they decided, well, they did a technical and practicability evaluation, and it's crazy, but the first of the option was to take out the 10,000 miles of underground workings down to bedrock. And it would have created, so then you no longer have oxygen and water pulsing through this underground mine system. So it would have cost almost $500 billion, and it would have made a pit about 60 times bigger than the Berkeley. So that is the granddaddy of all technical and practicability. They went through a couple other options, over 9 to 13 billion, and is what they finally decided is, we'll let it flood to a safe point, because the Berkeley Lake is the lowest point in 10,000 miles of underground workings. It all drains to there. It's a huge capture system. That's what the red line represents. And the arrows, of course, are groundwater direction. They turned off the pumps in 82, and that all started flooding. We all know the water was rising until 2019, and then they started pumping and treating that water and releasing it in Silverbow Creek, and that's a whole other story, but it seems to be working really well, actually. They meet their water quality standards. There's still questions about it, and they'll be working through making it better and better. As far as cleaning up Silverbow Creek within Butte, ARCO started the whole Silverbow Creek cleanup. This was the Colorado tailings at Silverbow Creek, running right around it. Pretty simple story. You dig up the tailings and cart them away. You rebuild this stream and floodplain with clean materials. This is the two aerial views. So there was the Colorado tailings. You can see they moved the stream. You can see they built a floodplain with a meandering channel. Interestingly enough, and sort of making this a more complex situation, the round circle is our sewage treatment plant, and then the red line is the discharge line. So it discharges right below. Oh yeah, I should have mentioned those ponds there are the groundwater treatment ponds. So they just add lime to the collected groundwater. And I'm not going to get into that very far, but interestingly is we rebuilt our sewage treatment plant it was finished in 2016. And it was built to take care of nutrients. And we could see, you know, total nitrogen went from 626 pounds per day down to 74, and phosphorus, similar huge drop, right? It's been pretty effective. No, it's been really effective. We probably have one of the most recent upgrades of any city in Montana. But what's really interesting is that under Superfund, there's something called a point of compliance above and below the sewage treatment plant. So the argument from DEQ and EPA was, we just need it down there below everything. And ARCO said, well, we don't want to be responsible for whatever's coming out of the sewage treatment plant. Good response, I guess. And so it's bracketed with these two sampling points, and those are monitored monthly. So we know copper levels above and below that monthly. So if you just take that data and on any January you measure upstream versus downstream, you can see whether it either gained copper or lost copper. And then if you just take every one of those months and add it again, so it gained 2 in January, it gained 3 in February, now we're up to 5. You get this curve. And so you can see the sewage treatment plant was adding a lot of copper back before they rebuilt it. And then after they rebuilt it, it is now dilution. Kind of interesting, I mean, it worked out for everybody.
Well, and part of the problem with some of the water going into the metro sewer plant is actually stormwater.
Yes, that's a whole. So, the other side of this, and you know, I said tailings and direct mine discharge, but there was all the waste piles on the hill, and when it rained, it looked like that water coming off looked like that, and it's loaded with copper, and that used to run straight into the creek, so you take waste piles like that and you cap them. That's a big part of the problem solved. That was 600 acres have now been capped and counting. They're still doing additional stuff. But one of the things that was in the amended ROD and the biggest agreement in the consent decree was to build additional stormwater retention detention ponds. So these fill up to a certain point, they retain the stormwater. There's a lot that reacts there. It's not just settling, but you have biological action, so it even reduces the fine fraction of copper, even maybe dissolved fraction. These are the ones that have been existing for a long time. This is called CBA, it's just below Iron Street. So let's move on to downstream abuse. So in 2000, downstream of Butte, DEQ started in 1999 or 2000, really, cleaning up the tailings along Silverbow Creek. And this is Ramsey Flat, and it was impressive how dead it was. This was the largest single accumulation of tailings anywhere. The Silverbow Creek at the Clark Fork.
Quick question, John. Were those tailings deposited from a combination of the flood and the discharge, the slurrying, or mainly the flood?
Oh, mainly the flood. I think that thickness was because of the flood.
Sure, okay.
You had to think there was stuff washing down, you know, every spring runoff, there was probably stuff washing downstream, but there's no reason there was that kind of a thickness.
Right.
Well, and the 1908 flood at Montana Street, it was 15 feet deep across there. So there was a lot of water backed up, and probably Ramsey Flats, the narrows as it got into Durant Canyon, that's why it had a little lake there until it drained.
Well, the other thing was Silverbow Creek coming out of Butte is in a pretty narrow canyon.
Yep.
And the first place it could spread out was at Ramsey Flat. And so, and you're right, then it's kind of cut off by the narrow canyon downstream.
That's what floodplains do.
That's what floodplains do. So those are, again, Ramsey Flat, those are copper salts. So in normal chronic conditions, in other words, regular day-to-day, whether it's high flow in the creek or not, mostly what's happening is you're scouring the bed and the banks and picking up tailings and putting them in the creek. But that's an acute problem because, and these copper salts would collect because you have groundwater wicking up to the surface on hot days, and then the copper salts are left behind as this. So imagine when it rains on that and that runs off into the creek, and copper salt, it's just like any salt, they dissolve, and so you have ionic copper going straight into the creek. On the Clark Fork, they documented high concentrations of copper and lots of dead fish a couple of times. And it's these vents, those kind of events. So same thing, they did the same thing Arco did. They did 26 miles instead of 1 mile. It took 15 years basically to get the bulk of the work done. And it cost $130 million. And there they are building a new channel. Anyways. So that's Ramsey Flat. That's a before and after of Ramsey Flat. So between Silver Bow in Butte and Silver Bow on stream side, what's the difference? So in Butte, we manage stormwater, capture and treat contaminated groundwater, remove tailings and rebuild the creek. And also cap a lot of mine waste, but, for stream side, it's remove tailings, rebuild stream and floodplain, no groundwater remedy component, no stormwater remedy component, but once you've removed those slicket areas, there's no longer salt building up at the surface, so there's no longer an acute problem. So back to our board game, and what is the record of decision based on? Well, it says we have these water quality standards and we just kind of expect you to meet those. So that's, you know, when you ask, well, when ARCO asks, well, what have we done? It's meet the standards we've established. And EPA always seems to say, we're really going to err on the side of caution. And we have our own water quality standards, the federal standards, but we're gonna defer to Montana's water quality standards. The difference being they're almost exactly the same, but for Montana standard, they take an unfiltered sample. For the federal standard, they filter it through a 0.45 micron filter. And they call it dissolved, it's not probably exactly dissolved, but.
So the state would be more stringent?
But the state is more stringent. So they can go with the state if it's more stringent or equal. They can't go if the state is less stringent.
So the highest standard they adhere to, whether federal or state,
Yes.
the cleanest standard.
Well, in this case, the state, they tend to defer to the state, I think, if they have a higher standard. So, this is where you may go to, you may consider waivers, or maybe they're considered upfront. And if that happens, it may require amending the ROD. So we all kind of know that process now. It's not a simple thing. Neither is a good TI evaluation. I already showed this, didn't I? So again, those are the two waivers. So this was my story back as a DEQ geologist working with lawyers. And this is in Anaconda, and I said, you know, we need to start collecting more biological data. And my lawyer said, I don't want to hear stories about happy fish. And it's what she's talking about is this is a lawsuit, and she may end up in court with EPA against ARCO, and she can't say, our biology says that the fish aren't very happy. But she can say, here's a clear, bright legal line, and it's not, and it's being exceeded, and you need to do something. So that was her story. But I said, but look, we're coming up with these TIs, and there may be waivers in the future. We don't want to then in the end say, well, I wonder how the biology really is doing. So I was trying to get, and they are doing more biological monitoring now. So let's look at the interface between biology and these standards. So like I said, this is my conceptual model of the ecological history. I mean, it's going to reach some asymptotic level. The hardest to meet is at the bottom, the state standard based on an unfiltered sample. The yellow is then the federal standard based on a filtered sample. And then above that is two water quality standards, at least for copper, that are recognized by the EPA currently. So they could be used. And relatively in the order I show as far as would it meet. These are, they call them the ARCO 5. I already had this picture of Moses up there. I decided to call them the Moses 5. Arsenic, cadmium, copper, lead, and zinc. So when are we done? EPA says when you meet DEQ standards, unless we decide to waive that standard, keep in mind, they still have to, they just can't say, throw out the standard, sorry, we can't get there. They have to define it as they are being protective of human health and the environment. So let's look at the way the standard works. So first of all, we're gonna look at the state standard, unfiltered, they call it total recoverable. It's based on the hardness of the water when you took the sample, so it's not a single number. It floats around depending on the character of the water. And it's inverse natural logarithmic function, so it's not a straight line either. But you can do this calculation, it is, so anyways, let's look at what's happened through time, and we're gonna look at what I call, no, I think we're gonna look at the circled part first, and that's right at the downstream end of Butte, because this have a longer history of this. The dots on, this is concentration of copper, micrograms per liter, parts per billion. The 6 samples on the left were done by John Spindler, who was the first environmental manager for the Anaconda Company. Back in the 70s, he was changing the operation and the amount of water and the character of the water that was being released from the mine. And you can see he made up over an order of magnitude difference. The upper number is the maximum, the lower number is the average. And then we turn off the pumps, and then we enter the history through Superfund cleanup. So now we're gonna look at Silverboat Creek all the way downstream at Opportunity. And so there's the concentrations of the Arco 5, or the Moses 5. And we can see at the bottom is cadmium, at the top is actually zinc, arsenic's the green. But what I could say, what does that mean to you? What does that mean to a fish? Well, the easy way to figure that out is we'll just apply, every time we take a sample, we'll measure the hardness and we'll calculate the standard, and then we'll take the ratio between the concentration and the standard. And I don't know if that sounds complicated or not, it would to me if I didn't already know it, but just means if it's above 1, if the ratio is above 1, you're exceeding the standard. Pretty simple, and it turns it into a picture of, are the fish happy? As far as just looking at water quality standards, are the fish happy? So this is the state standard. You can see we've made 2 orders of magnitude difference in this, and this is the whole cleanup. Remember, this is all the way downstream, right above the ponds. I don't know what happened the last little bit there in 2023. But
Low water,
huh?
low water, low stream flows.
No, if anything, it would have been high water.
Okay.
And you'll see that in a minute. So, okay, what if we looked at it with a filtered sample? Then it looks like that. So it's actually meeting the federal standard down at Opportunity. So we're gonna take a quick look at Blacktail Creek, which I consider sort of this background. And then we're gonna look at right below the work that was done in Butte. And then we're gonna look at all the way down at just above the ponds. So there's Blacktail Creek, and this is again copper, and we're looking at the compliance ratio. So it just looks pretty flat, no real changes. There's just usually the high points are high flow, so it's picking up more particulate copper. So there is Silverboat Creek right below Butte. You can see sort of the high part where it was really high on the left-hand side. It jumped up when they were digging up the Colorado, and because, you know, it's called breaking eggs to make the omelet. But then you can see this incredible decrease. There's a lot of steps along the way, like in taking out the groundwater. There's a lot of things that happened in there. And then there is all the way down at opportunity. So we can see you can see the sequence in time that Butte was happening faster than downstream, yada, yada. This is then looking at, again, the filtered. And I think this is kind of funny because there at the right-hand side, the light blue is Blacktail Creek. So it seems like our background is the one exceeding the federal standard for copper. Now let's move beyond and talk about a couple other standards that EPA allows. And remember, this is based on sound science, as sound as science can be, really. And the first one is called, I should have put in, I have another graphic that I should have shown, but the water effects ratio work here was done by Atlantic Richfield. And they measured like 3 different sites on Silverbow Creek, and they did the mouth of all 4 streams in Anaconda. Not only, and I'll explain water effects ratio, but it also said, their work also said a lot about the biotic ligand model. But not only did they collect all of those samples from those sites, they did it in winter, spring, and summer, fall. So winter, low flow, base flow conditions, spring, high runoff, summer, fall, again, base flow, basically, although there may be a storm event affecting things. So this is where I should add another slide. When they first come up with a water quality standard, it's pretty easy to explain. You take an organism, let's say a rainbow trout, which they used here, or a Ceradaphnia, which is a little tiny amphibod, and you put them in a tank, and then you start adding copper until you've killed half of the population in the tank. And that's an endpoint. And it's called the LC50, or the lethal concentration that has killed half of the population. So they do that on a number of different organisms and a bunch of different metals. But what they've done is they've taken water and they say, we're gonna make generic stream water. So it's called lab water. And so it's supposed to represent any stream in the world. But in reality, streams have very much their own characters. And so what EPA said is, ARCO, they didn't say this specifically to ARCO, but they said, industrial person, you can rerun these experiments. You can go collect the water out of the stream you're working with, and you can run these experiments side by side. So, like I said, they use rainbow trout and Ceradaphnia, 2 different organisms. Honestly, a lot of the data that goes into this is based on a whole slew of organisms. But then you just simply say, what was the LC50 for the lab water? What was the LC50 for the site water? And you come up with a ratio. And it simply says, well, we could take the state's water quality standard, and in the case of the wintertime, just multiply it by 2. So if the standard was 10, let's just call it 20. Okay, so that's how that works. But what's kind of interesting is winter and summer, fall, it's roughly 2, a little below 2, a little slightly above. But in spring, when we have runoff, the ratio is almost 4 to almost 6. So much higher.
And that's your 3rd column, WER.
Yes,
Okay.
that's my 3rd column over this. Does that make sense? Thanks for, I mean, honestly, folks, I get lost when people are showing me graphs, so.
Hey, Joe, can you go back and just tell us what that stuff means? I didn't follow that.
Daryl, we'll have a private conversation later. So I'm gonna skip to Warm Springs Creek. If I tried to do this with Silver Bow Creek, there's been so much change, I couldn't see a consistency. I guess I could have done it with Blacktail Creek. But they did a really nice job on Warm Springs Creek, getting all of those, all that seasonality. And, so, again, the low numbers in that graph are base flow conditions. In other words, groundwater is basically feeding the water in the stream. The spikes are spring runoff, and you can see the difference. This is concentrations, this isn't the compliance ratio, but you can see it's a difference of maybe 10 to going up to 90 over 100. I mean, it's a huge difference in the amount of copper that's in the stream.
Okay, and that's at the confluence of where Warm Springs comes into the Clark Fork.
Yes, that's
Okay.
right at the mouth of Warm Springs
Right.
Creek. Yeah, good point. And this, again, is these are the unfiltered samples. So, what's going on is you just ask the question, well, we know every time they took a sample, we knew what the flow was. So you just do this analysis where you can compare copper concentrations on the Y against discharge or flow on the X-axis, and you can see pretty clearly there's a trend, which is the same thing the other graph was showing us. But here's the catch, is that as flow goes up, hardness goes down. And the same, because the standard is based on the hardness, the numeric value of the standard is going down. So you got copper going up, the standard going down, makes it really hard to meet the standard. But again, that doesn't make sense. Look, on the very right-hand column, when we have high flow, we have a higher ratio. Is what's going on is dissolved organic carbon. That is a really good description of toxicity, of an ameliorating factor of copper in a stream. So it's kind of the same, you know, you look at hardness and you're saying, well, if there's more calcium, it's kind of protective. In this case, dissolved organic carbon beats out calcium by a long shot. It's because carbon will tend to absorb things like copper. It has a lot of negative surfaces, or it's basically negatively charged, and so copper and zinc and cadmium are all, they have a +2 charge. So it kind of takes them away from going to a gill surface, which has a negative charge, which would tend to attract a copper ion.
So that's basically biochar kind of thing, or?
No, that is how biochar works, exactly right. Same difference. This is at a organic molecular level supposedly, but it's just filtered to 0.45, which is quite a bit bigger than a lot of molecules.
So that's organic carbon flowing in the stream?
Yes.
Okay.
Yes. And there's total carbon in the stream. That's another thing you could measure, but total organic carbon. In this case, I'm just showing the same thing, honestly, and this is again back to total recoverable, and it's the compliance ratio. This is Silver Bow Creek down at the downstream station. And as all I did was through this period of time, I said, I'm gonna just look at the maximum compliance ratio and the minimum compliance ratio, because the maximum is gonna represent the best check on high flow, and the minimum is gonna be base flow. So we can see, we can see Silver Bow Creek cleaning up, but we can also see the vast difference again in Silver Bow Creek between base flow and spring runoff flow. So this paper amazed me, and I started sending it out to anybody I could think of, honestly. This guy, Dr. Christopher Meebane, has been in this realm of trying to figure out toxicity of river waters, and particularly metals, for a long time. And 2023, that's really recent, honestly. You see a lot of these papers and they go back to 1990, 1980s, 2000s, 2005. I just went, wow, there's a good one. And I started looking at it as what Dr. Mebane did was he took tons and tons, you should see the bibliography or the reference section. He took tons and tons and tons of research and reprocessed. He came up with a couple of conclusions. Clearly, the BLM is far superior to the hardness-based standard, but there was another one, it's called multiple linear regressions, and I don't understand that one. Well, I kind of understand linear regression, but I don't know how you do multiple linear regressions, but you're looking at various factors and comparing them linearly separately, but then all together. So you come up with, say, copper might account for 50% of the toxicity of the water, or something like that. So, anyways, I thought this was interesting. The hardness-based criteria performed poorly with all toxicity data sets, showing no or weak ability to predict observed toxicity. I actually decided I needed to talk to this guy. And he sounded almost apologetic for making that statement, but it comes directly out of his abstract. So one of the things about the hardness-based standard is that in some cases, it may underpredict protectiveness, and in some cases, it may overpredict protectiveness. And so in the spring, it's underpredicting. In other words, hardness-based standard says it's 10, the BLM says it should be 14. But the other part is worth considering too. Sometimes the hardness-based standard, it should be 14, and the BLM says it should be 4. So it's not just a one-way thing, right? It's not always. Yeah, it's not always making ARCO's life in these cleanups or DEQ's life in these cleanups easier. Sometimes it may say, hey, this came out in 2022, and it's kind of the same thing. They just, EPA looked back through, they have a big research arm, honestly, and they went back and looked through a lot of data, and in the bottom there, those are scores, those numbers there, and this is for copper and lead, and I obviously just extracted this out, but those are scores of effectiveness. And so the BLM for copper is 0.55 and the multiple linear regression is 0.87. So I would like to learn more about multiple linear regression. So let me see where I was going with that. Oh yeah. So interestingly, DEQ for 2 years collected dissolved organic carbon. So they had the first data set that they could actually run the BLM, and it was 2015 and 16 or 14 and 15. But they have sampling sites from Butte all the way to Missoula. So let's look at how that turned out. And again, this is BLM applied to this is again a ratio. And so these are box and whisker plots. The dark bar is either the median, I think it's the median value of all of those, and it was 2015 and 16. So we can see all the way back up, let's see. So the first 3 box and whiskers on the left-hand side are Blacktail Creek at Harrison Avenue, Silverbow Creek below the Slag Canyon, and Silverbow Creek above the wastewater treatment plant. So then above the wastewater treatment plant, it jumped up. Remember, 2016 is when we took copper out of the wastewater treatment plant. And then,
I was just thinking you could use your mouse and so to be able to see it on the other side.
well, So that one's an interesting jump too. And that's getting further evaluation, right now by DEQ. I don't know what's with these. I think it's maybe that they were just completing, streamside cleanup in 15 and 16. Be interesting to see them now. But the interesting thing is, look what the Warm Springs Ponds does to everything. I mean, the Clark Fork is complying with copper standard. This is only copper, let me make that clear. This is only copper, but everybody is, copper's the biggest boogeyman of them all, generally. It's been needing it for quite a while. And obviously, just to make a point, because the Warm Springs ponds are going to be looked at next, are really doing a job. If you're worried about metals. So, I said, no, what about biology? And there's been a lot of good biology done. This is Dave Stagliano collecting macroinvertebrates. That's a hydropsyche caddisfly. And he just puts cobbles in that bucket there and scrapes the bugs off and collects them in a little cup, takes them back to a lab and speciates them and counts them and does all sorts of good stuff with them. And these are the stations that Dave does. Dave actually picked up this study from Dan McGuire, who started this in like 1986. So this has got a good long data set, and it's got great spatial distribution. This is an impressive data set. I wish that they would start paying for Dave to do Warm Springs, Willow, Mill, and Lost Creek as well. So this is what it looks like through time. 86 here at the left, and 2023, the latest report I could get my hands on. There should be the 2024 report out soon. But what we're doing is there are 13 stations there. We're counting how many stations are in what category. And the categories are severely impaired, moderately impaired, slightly impaired, and then the green is non-impaired. And those are qualitative assessments done by a bunch of biologists. So it's relatively believable, but it obviously shows improvement. The severely impaired there is certainly Silverbow Creek in the past at Opportunity. It was certainly, may have been below the Mill Willow bypass before they cleaned up the Mill Willow bypass. And it probably included Deer Lodge. But if we look all the way since 2019, there hasn't even been a moderately impaired station in this whole network. And the funny thing about this is all about above Milltown. This doesn't include Milltown. They didn't start cleaning up the Clark Fork until, this doesn't include anything on the Clark Fork because it started in about 2014. They started cleaning it up. So a lot of this was kind of naturally recovering in some respects. So let's look at Dave Stagliano's data right there at Silverbow Creek at Opportunity. And that's what it looks like through time, starting in 85 or 86. And the blue line is the overall biointegrity, and it's now bouncing back and forth between non-impaired and slightly impaired. The orange is actually a subset, and it's a metal-sensitive biointegrity. So removing the metals out of Silverbow Creek has had a definite effect on aquatic life. Another study that's been done was Michelle Hornberger, and hers started, I think, in the late 80s, but this data set goes to 1992. The blue bars are Silverbow Creek at Opportunity, and the orange bars are Warm Springs Creek. she comes every August, she was coming every August and collecting these hydropsyche caddis flies. She'd take them back to the lab at the USGS station at Menlo Park, and she would figure out how much copper is in their bodies. So it's a measure of how much exposure might be occurring out there to aquatic life. There's a lot of reasons why this particular caddisfly is important to this, but Warm Springs Creek, which they only do every third year, has stayed roughly the same. Maybe it got a little bit better there the last 6 or 12 years. But obviously, Silverwell Creek has gotten a lot better. It's almost starting to match Warm Springs Creek. So back to my basic thesis is, I think we should be looking at all of these streams as a whole. And we should be actually maybe comparing different parts to say Warm Springs Creek and Blacktail Creek. So weight of evidence approach using a couple of reference streams. So here's Silverbow Creek. That is outstanding stream habitat. That was CDM actually sampling during high flow. I don't remember how long ago that was, but Warm Springs Creek, as we saw, has this copper problem, definitely a copper problem. But it's a healthy ecosystem. That's why I want to use it. But it's also interesting because the old works slurried their tailings directly into Warm Springs Creek. And it was also obviously probably affected somewhat by smelter emissions. So I took out the one with arsenic because I wanted to move this along. But these were floodplain samples that were taken before the floodplain was kind of cleaned up. They removed a lot. At the bottom, you see section 32, NRD, Guckenauer, Johnson. That's from upstream to downstream. And this is after it's left the Anaconda Valley and it's moved up into the greater greater Deer Lodge Valley. But you can see, and along the x-axis is the depth that the sample was collected. So you can see at the shallowest depths, and really going fairly down there, 30 inches, you can see those ones, those dots above 10,000. 10,000 is 1% copper. So do you think there was copper in the floodplain here? The mine currently mines about 0.25% copper.
Well, we should mine it then.
I know, we could mine it. So this is what, which one do I have? This is unfiltered sample. This is what Warm Springs Creek at its mouth looks like with the compliance ratio. So we can see it's copper and it's a little bit lead. And I can also tell you Willow Mill also look a lot like this. So really, what's Warm Springs Creek like? Well, this is FWP out electroshocking and doing fish counts. On that day, we got that brown trout. And I said, hold that there for a minute. Let me take this picture. This was back a while. This is, I don't remember, probably around 2000 maybe. But FWP will tell you this is a fairly healthy ecosystem. They really appreciate Warm Springs Creek. Everybody loves Warm Springs Creek. So I think it makes a great reference stream in that it says a lot about maybe copper at least isn't as toxic to aquatic life as we think. Maybe there's better measures. But let's look at Blacktail Creek. So this is Blacktail Creek currently. Somebody said, it looks like a spring creek, and yeah, it does, actually. And interestingly enough, this is just a little ways upstream of the visitor center. And that is a big upwelling, groundwater upwelling area in the creek. So it is it's got both upstream coming in there, but it's got a lot of groundwater discharge, so it is kind of a spring creek in a way. But look at that habitat, that's outrageously good habitat, honestly. So this was taken at the same time those pictures at the confluence was taken. I put boomers up there because I looked at this picture and went, that would have been me, that's from the fifties. Whatever, jeans rolled up like that, yeah. But that's the butte reduction work stack. And you can see how straight Blacktail Creek is, and.
That's kind of about where the visitor center is now.
Yep, well, the
To the
visitor
right.
center would be right to the right of
Yeah.
that. You can see the piles that are still left on the right-hand side of the creek. So they've just dredged this to keep water moving through here, just like they did the Metro storm drain.
Yeah, because they were swamps.
Yep, but I'll take you back to unfiltered copper compliance on Harrison Avenue through time, all the way up to 2024. It just doesn't meet standards, but how about the biology? Well, I've gone out with FWP a number of times to do their electroshocking. This is up at Father Sheehan Park. How's that for habitat? You can't hardly see them in the creek, and the creek's about that wide and kind of about that deep, maybe that deep. You'd think, what, why are they there? But they collect buckets and buckets and buckets of mostly brook trout. So that was one of the better sized brook trout we caught on that day. But it's funny, it's a really incised channel there too, because I'm standing right next to what was the war bonnet taking this picture, and I'm looking down at them. And those guys are probably 6 feet tall, so I'm probably standing 7 feet above the creek. And on the other side, it's a little lower, but this is just kind of really down there in this deep slot. But boy, do the fish thrive there. So kind of getting back to my whole thing and all of these standards. So getting back to my argument with my lawyer, are we interested in numeric values, or are we interested in number of fish? And I had to throw that picture in too, because I just really like that one.
You must be standing on the girl's side there, taking that picture.
I was, yes. In my rolled up jeans. So are there any questions? And that's Nora Sachs, and that's Rye Vincent.
Wow.
And that's right at the confluence.
Any questions, anybody?
Come on, Daryl, you can throw a hard ball at me.
When's the test?
I'm looking at Daryl. Joe, how does this relate to our current record of decision and the potential waiver to the BLM model? It sounds like the BLM model is ultimately better for copper, but it's not always easier to meet. Is that what you said?
No, not exactly. I said the BLM, I would simply say it looks like the BLM is a better definition of toxicity. It explains toxicity far better than the hardness-based standard. And right now, the three the three TI waivers in Butte. First was the Berkeley pit water. Then there was the alluvial groundwater in Area 1, which is from the concentrator down to the interstate overpass. And the third one was stormwater. So they only weigh copper and zinc for stormwater. I think, again, implied is in the consent decree, they defined a ton of work that could be done, that needs to be done, that ARCO agreed to do. So when that's done, if they're still not meeting standards, I would say they would still reconsider additional waivers.
Yeah, but my question's really, when you look at the sequence of waivers in the ROD, the state dissolved is the first goal. If that can't be met, then it's the federal total, and if that can't be met, then it's the BLM, which would make it seem like the BLM is easier to meet. But I think what you've shown us is the BLM is actually better, but there's some seasonality that the BLM is easier to meet in some seasons and not in others.
No, no, and I don't know that the CD, I don't know that anything in the CD, so is all they waived was the state's total recoverable standard for zinc and copper during storm events and in the stream. And they waived it to the federal filtered or dissolved standard. So they didn't do anything. You do raise an interesting question that has
I'm
been raised.
looking at the table right now. It goes chronic surface water standards, goes from state, right, state total, no change, and then it goes to BLM post-construction if a waiver is needed.
Oh,
So-
I didn't know it had BLM in it. Interesting. And
Okay,
is that for acute or chronic conditions that you're reading from?
this is chronic.
Oh, okay, good, okay.
Yeah.
So they
So
just go straight to BLM.
All right.
I
Yeah, so
know,
my question
ahead.
was really, had you thought about whether it's would be best to just shoot straight to the BLM waiver if that's ultimately the better fish toxicity metric?
well, the whole idea is to set up what you think is the best work that could be done. And then do that work and then before you go to another standard, I guess. And honestly, I think in some cases, it could possibly be doing more harm than good, and maybe it would be better to go. I guess if I was king, I know there are places I would go straight to the BLM right now.
All right.
And not necessarily here, I'm just saying that's kind of the way I would look at some of it, but like I said, I appreciate all of the work, and all of the analysis and all of the designing that went into, coming up with a final plan of what to get done. And the biggest part in Butte by far was really, a lot more stormwater, capturing a lot more stormwater. And that'll be really effective at removing, a vast amount of copper and zinc and everything else. It's very, the stormwater ponds we do have are, very effective. They remove up to 95% of the total recoverable copper. That's pretty impressive.
And the monitoring that's been done over the years, you could go back and use that to determine if it met the BLM standard or not? Or is there certain other monitoring needs to be done that isn't being done?
You can do it in Silverbow Creek and Butte. And you can do it in the four streams in Anaconda. That's the only places they've collected dissolved organic carbon.
Okay,
And except for when DEQ collected 2 years on all their sites. So, and I've kind of appealed to EPA and to the USGS that they start including DOC everywhere. I'm not king and they don't necessarily listen to me.